In the vast darkness between galaxies, the Milky Way glows like a faint lantern in a limitless night. For centuries, we believed it was enormous, a swirling city of suns stretching across the cosmos, a place so vast it defied comprehension. But the deeper we look, the smaller it becomes. New maps reveal a humbler truth. Our grand spiral of light is not the giant we once imagined, but a fragile island, modest among billions. Every star, every planet, every story we've ever known, all contained in a space that could vanish in the blink of cosmic time. If our entire galaxy is this small, what does that make us? Like and subscribe if you love stories that blend science with wonder, and join us as we trace the true borders of our tiny home. Let's begin. At the edge of everything we can see, the light of distant galaxies stretches into whispers. Yet, even as our telescopes capture trillions of stars, new data reveals a sobering truth. The Milky Way is smaller than we ever imagined. Its borders aren't carved by starlight, but by gravity's reach, and that reach, it turns out, is far more limited than we once believed. For decades, we pictured our galaxy as an enormous spiral of light, its arms stretching out like ribbons across the cosmic sea. It was comforting to think we lived within something colossal, a structure that could hold its own against the infinite dark. But as scientists began mapping the Milky Way with extraordinary precision, they discovered that the horizon of our home, the place where its gravity fades into the void, lies much closer than anyone expected. The empire of stars we once imagined turns out to be more of a delicate island, floating alone in an ocean of nothingness. Using data from the Gaia spacecraft, astronomers traced the motion of over 1 billion stars, measuring how fast they move and how far they drift from the galactic center. What they found was startling. Beyond a certain distance, the stars no longer move as if they belong to us. They begin to fall away, caught by the faint pull of neighboring galaxies, slipping quietly across the invisible border between what is ours and what is not. For the first time, we could see the Milky Way's true edge, and it was far nearer than our stories had told. Once, scientists believed the Milky Way's disk extended more than 200,000 light-years across. Now, refined models place its active star-filled region at less than half that width. The grand spiral arms fade into sparse dust and faint, dying suns until even gravity's hold begins to falter. It's as though we've walked to the edge of a great forest, only to find that beyond the last trees, there is nothing but mist. This shrinking horizon changes more than just numbers. It changes our perspective. Every photograph we've seen of the Milky Way's sweeping arc across the night sky is a portrait painted by distance and illusion. In reality, the galaxy's edges dissolve gradually, like smoke thinning in the air. There is no clean border, no final ring of stars, only a quiet surrender to the dark. The universe does not announce where one galaxy ends and another begins. It simply fades. Astronomers call this outermost region the stellar halo, a sphere of ancient stars surrounding the galactic core. It was once thought to stretch hundreds of thousands of light-years into space, but new measurements show it is surprisingly compact, tighter, denser, smaller. The Milky Way, it turns out, is not the sprawling kingdom of light we imagined, but a modest island city surrounded by emptiness. And yet, there's something deeply human about this revelation. The smaller our galaxy becomes, the larger our sense of wonder grows. To know that everything, every star, every world, every heartbeat exists within a single fragile spiral makes existence itself feel precious. We are not lost in infinity. We are held within something finite, measurable, and real. Perhaps the horizon was never truly vanishing. Perhaps it was simply waiting for us to look closer, to realize that in the grand silence of the universe, even something small can still hold everything we know. For decades, astronomers estimated our galaxy contained 400 billion stars. But with the precision of the Gaia and Webb observatories, that number is shrinking. Star by star, we're realizing that much of the light we thought belonged to us belongs elsewhere. For centuries, the Milky Way has been a symbol of immensity. When we looked up and saw that glowing river stretching across the night, we imagined an endless multitude of suns. It seemed only natural that a galaxy so beautiful must be boundless. But science, with its quiet precision, has a way of humbling us. As our instruments grow sharper, the illusion fades, and what remains is a truth both smaller and more intimate. The Milky Way does not contain 400 billion stars after all, perhaps only 100 billion, maybe fewer. In cosmic terms, that makes us a lightweight, a quiet spiral adrift among brighter, heavier giants. The reason for this correction lies not in our imagination but in measurement. The Gaia spacecraft, orbiting far beyond Earth's atmosphere, has mapped the precise positions and movements of over 1 billion stars, tracing their orbits like cosmic fingerprints. This data, combined with the infrared eyes of the James Webb Space Telescope, allows scientists to see what was once hidden by clouds of dust and distance. When they counted carefully, they found gaps, voids, and silences where light should have been. What we once mistook for countless stars were, in many cases, distant galaxies, peering through our own, their light blending seamlessly into the background of the Milky Way's glow. Each correction brings us closer to reality, and with it, a new understanding of our place in the cosmic hierarchy. Galaxies like Andromeda and Triangulum, our nearest neighbours, may contain twice as many stars as ours. They are true giants in the local group, while the Milky Way is revealed as something quieter, smaller, denser, less extravagant, but no less alive. It is a strange paradox. The more precisely we measure the universe, the more it seems to shrink around us. Yet, in that shrinking lies a deeper beauty, because to count the stars is to listen for their stories, each one a sun, each one a possible home, each one a fragment of the Milky Way's song. Whether there are 100 billion or 400 billion makes little difference to wonder itself. What matters is that we can count it all, that across the unimaginable gulf of space, our minds can reach and comprehend. Astronomers often say that every number we find in the sky is a lesson in humility. Once we thought the Earth was the center of everything. Now we discover our galaxy too is not the grand empire of stars we dreamed it to be. It is smaller, yes, but also more precise, a cosmic neighborhood instead of a kingdom. In the stillness of night, when you look up and see that hazy band of starlight, remember this: every glowing point you see is part of a count still unfinished. The numbers change, but the mystery endures. To count the uncountable is not to confine the universe, it is to be reminded that even in knowing less, we are still surrounded by more than we can ever grasp. When viewed from the vastness of intergalactic space, our Milky Way becomes a faint shimmer beside hundreds of other galaxies in the local group. To them, we are just one more point of light, a whisper in a crowded room. From within, our galaxy feels endless. Its spiraling arms cradle billions of suns, its dust clouds stretch across the night like smoke from an eternal fire. But when we step back, not in distance but in imagination, something humbling happens. The Milky Way fades into context. We realize that we are not alone in our corner of space. We share it with a quiet congregation of galaxies drifting together, bound by the soft, invisible pull of gravity. Astronomers call this small gathering the local group, a collection of more than 50 galaxies orbiting one another in slow, majestic silence. At its heart are two giants, the Andromeda Galaxy and the Milky Way. Together, they make up nearly all the mass of the group, surrounded by dozens of smaller companions, tiny, faint galaxies that orbit like fireflies around lanterns. Each one is a universe unto itself, filled with its own stars, its own worlds, its own possibilities. Yet, when viewed from afar, even the grandest among them are mere flecks of light floating in the cosmic dark. The local group stretches across 10 million light-years, a vast but intimate neighborhood on the scale of the universe. Beyond it lies the Virgo supercluster, and beyond that, the grand cosmic web, a network of filaments and voids that make up the large-scale structure of everything that exists. To imagine the Milky Way's place within that web is to imagine a grain of sand suspended within a vast coral reef. Beautiful, yes, but small, unimaginably small. What binds our local group together is gravity, the same force that keeps your feet on the ground, but stretched across unimaginable distances. For billions of years, this invisible thread has drawn the galaxies slowly toward one another. The Milky Way and Andromeda are on a collision course, destined to merge into a single larger galaxy in about 4 billion years. To the stars themselves, this is not a disaster, but a kind of cosmic rebirth. Their orbits will blend, new stars will form, and a new galactic shape will emerge. But for now, we are neighbours drifting closer, step by gravitational step. If you could hover outside the local group and look back, you would see a delicate balance of motion and silence, galaxies spiraling, colliding, and drifting apart in slow motion. The Milky Way would not stand out. Its spiral arms, so grand to us, would be no brighter than a single note in a symphony of light. To distant observers, our galaxy is simply one among countless others, its voice blending softly into the cosmic choir. And perhaps that's the most grounding truth of all. For all our searching and our science, for all our longing to be special, we are part of something collective, a small neighborhood in an infinite city of galaxies. Our sky, our stars, our entire history exist within one faint shimmer in the dark. And yet, within that whisper, life arose. Consciousness opened its eyes, looked outward, and saw the neighborhood for what it truly is, vast, interconnected, and quietly alive. Modern astronomers trace the Milky Way not with lines on parchment, but with gravity itself. Every star's motion reveals the shape of the galaxy, and as the data settles, the grand spiral we once pictured is tightening, revealing a humbler home. For most of history, our ancestors mapped the heavens with their eyes. They drew constellations, named them after gods and creatures, and built stories to explain their patterns. The sky was their canvas, and imagination was their instrument. But today, the art of mapping has evolved into something far deeper, a science that listens, measures, and calculates the motion of stars with extraordinary precision. Instead of ink and paper, astronomers now draw their maps with gravity, tracing the invisible choreography that holds the Milky Way together. Every star in our galaxy moves. Some orbit close to the center, whipping around the supermassive black hole like sparks in a furnace. Others drift lazily in the outskirts, taking hundreds of millions of years to complete a single revolution. By studying how each of these stars moves, scientists can infer the shape and size of the galaxy itself, not from what it looks like, but from how it behaves. It's a kind of stellar cartography, one where motion becomes a language, and gravity the pen that writes it. This monumental effort has been led in part by the European Space Agency's Gaia mission. Launched in the 2010s, Gaia has mapped more than 1 billion stars in 3 dimensions, recording their distances, directions, and velocities with a precision once thought impossible. When its data was combined with that of the James Webb Space Telescope, a new picture began to emerge, one that contradicted centuries of assumption. The Milky Way, it turned out, was not the perfect grand spiral we once imagined. Its arms are uneven, warped, and faint. And its overall size, the very breadth of its starlit disk, is far smaller than most textbooks used to claim. The more precisely we map our galaxy, the more it contracts. The lines that once stretched far into the dark are now folding inward, corrected by gravity's subtle equations. What we once thought of as sprawling arms now appear as tightly curved arcs, looping closer to the center than ever imagined. The Milky Way's shape is not the elegant, symmetric pinwheel of our childhood posters, but a warped and asymmetrical swirl, beautiful, imperfect, alive. And yet, in that imperfection, there's a strange comfort. The more detail we uncover, the more the galaxy begins to resemble everything else in nature. Irregular, evolving, and fragile. Our home is not a monument frozen in time, but a living structure, breathing through motion, rippling with gravitational waves, shifting slowly with every passing epoch. Each new map we create makes our galaxy smaller in scale, but infinitely richer in meaning. Because to map the Milky Way is to understand not just where we are, but who we are, explorers of infinity, drawing the boundaries of our home in lines of light and motion. The parchment may have changed, but the purpose remains the same. We are still, after all these centuries, map makers of the unknown. For most of the 20th century, we believed our galaxy was vast, majestic, and symmetrical. But new three-dimensional maps show its arms are lopsided, warped, and uneven, a reminder that beauty, even in the stars, rarely follows perfection. For generations, the Milky Way was drawn as a flawless spiral, elegant and balanced, spinning in serene harmony. It was the image found in textbooks, on observatory posters, and in the imaginations of dreamers everywhere, a perfect pinwheel adrift in the dark. We pictured ourselves living within a cosmic masterpiece, a grand design stretching across 100,000 light-years. But now, with modern instruments tracing every flicker of starlight and every wisp of dust, that perfect symmetry has dissolved. The Milky Way, as it truly is, looks far more alive and far less idealized. Data from the Gaia mission and radio telescopes like ALMA have revealed that our galaxy's spiral arms twist unevenly, their shapes distorted by gravitational tugs from neighboring galaxies, ancient collisions, and the restless movements of stars. Some arms fade into broken fragments, others curve too sharply or swell unevenly with dense clouds of gas. Even the disk itself, the plane in which most stars orbit, is not flat. It bends upward on one side and downward on the other, like a great sheet of light caught in a slow, invisible wind. This discovery shattered one of astronomy's most persistent myths, that galaxies are stable and symmetrical structures. In truth, they are messy, restless, and ever-changing. The Milky Way has been sculpted by violence, shaped by impacts with smaller galaxies, twisted by gravity's tides, and bent by unseen waves of dark matter. What we once thought was order is, in reality, a delicate balance of chaos. And yet, there's something deeply poetic in that imperfection. When scientists modeled the true structure of our galaxy in 3 dimensions, they found not disorder, but life. Each distortion, each ripple, tells a story of cosmic encounters and survival. The warp of our disk may be the lasting memory of an ancient collision. The uneven arms could be the footprints of galaxies long absorbed. Even our spiral shape, so iconic and fragile, may one day dissolve entirely as we drift toward our eventual merger with Andromeda. The Milky Way, then, isn't a monument of geometry. It's a living organism, bending, flexing, and growing in the slow rhythm of cosmic time. Its beauty lies not in perfection, but in persistence. Despite the forces that pull and twist it, despite the gravitational tides that threaten to scatter its stars, it endures. Perhaps that's why we find it so captivating. We see in our galaxy's asymmetry a reflection of ourselves, imperfect, evolving, scarred by time, yet still radiant in motion. The myth of the grand spiral was never wrong, it was just incomplete. For in truth, the Milky Way's wonder doesn't lie in how perfectly it was made, but in how beautifully it continues to change. From a side view, the Milky Way isn't flat at all. Its outer edges twist upward and downward like a cosmic wave, the result of gravitational tugs from neighboring galaxies, proof that even giants can be bent by unseen hands. For decades, the Milky Way was imagined as a perfect disk, thin, even, and stable. We pictured it like a celestial record, spinning gracefully through the dark. But the more precisely we've measured its stars, the more that illusion has unraveled. Our galaxy is not flat. It bends and ripples through space, its vast edges curling up and down as though caught in an eternal tide. This gentle warp, stretching thousands of light-years above and below the galactic plane, is one of the clearest signs that the Milky Way is alive, constantly shaped and reshaped by invisible forces. Scientists first suspected this distortion when they noticed that distant stars didn't line up the way they should. When viewed edge-on, the outer rim appeared to tilt, bending slightly upward on one side and downward on the other. For years, this was dismissed as an error, a trick of dust or distance. But as Gaia and radio surveys mapped the positions of millions of stars, the truth became undeniable. The Milky Way's disk is warped, twisted like a spiral blade caught mid-turn. What could bend something so massive? The answer lies beyond our borders. Around the Milky Way drift dozens of small satellite galaxies, their combined gravity pulling at our outer stars like children tugging at a giant's robe. Over time, these faint companions, including the large and small Magellanic Clouds, have stirred the Milky Way's edges, setting them into slow, rhythmic motion. Even Andromeda, far across the void, exerts a faint tug. The result is a galaxy whose form is constantly flexing, a spiral caught in a cosmic breeze. The warp moves too. It precesses, slowly rotating around the galaxy's center like the wobble of a spinning top. To the human eye, the change is imperceptible, unfolding over hundreds of millions of years. But in that patient motion lies a quiet truth. Nothing in the universe is perfectly still. Even the grandest structures drift, bend, and yield to unseen rhythms. From our position inside one of the spiral arms, we can't see this tilt directly. To us, the Milky Way appears as a flat ribbon of light across the night sky. Yet if we could step outside, if we could look back from a few million light years away, we'd see our home curving gracefully through the dark, like a shimmering wave frozen in mid-crest. It is not rigid, it flows. And perhaps that is what makes it beautiful. Perfection, after all, is lifeless. But this tilt, this subtle warp, is proof of motion, proof that our galaxy responds to the touch of others. Even giants bend. Even vast empires of stars are not immune to the quiet pull of neighboring hands. And as we drift through the dark, twisting gently in the gravity of the unseen, we are reminded that to be alive in the universe is to be shaped, always, endlessly, and beautifully so. We once imagined our galaxy surrounded by a vast invisible sphere of stars and dark matter. But newer observations show that this halo, the Milky Way's invisible skeleton, may be far smaller and denser than expected. For years, astronomers believed the Milky Way was wrapped in an enormous ghostly halo, an unseen cocoon of ancient stars and dark matter extending hundreds of thousands of light years into space. This halo was thought to be the true structure of our galaxy, dwarfing the bright spiral disk we see in the night sky. It was the foundation of our cosmic identity, the hidden frame that gave our galaxy its strength and mass. But recent studies have forced a quiet revolution in how we understand that invisible boundary. The halo, it turns out, isn't the sprawling sphere we once thought it was. It's smaller, tighter, and far more intricate, a hidden architecture now being redrawn. The evidence comes from missions like Gaia and from the careful measurement of distant stars that orbit beyond the Milky Way's visible arms. By tracing how these stars move, scientists can infer how much unseen matter surrounds them. What they've found is surprising. The outermost stars are moving slower than predicted, suggesting there's less mass pulling on them from beyond. In other words, our galaxy's dark matter halo may end far sooner than we believed. For decades, models placed the edge of the halo as far out as 300,000 light-years from the galactic center. But modern calculations shrink that number dramatically, perhaps closer to 100,000 light-years, maybe even less. That's still an unimaginable distance, yet in cosmic terms, it makes the Milky Way far smaller and lighter than its peers. Once we were thought to be one of the heavyweights of the universe. Now we may be something closer to average. But this revelation doesn't make our galaxy any less fascinating, it makes it more mysterious. Because the halo isn't empty. It's filled with ancient remnants, globular clusters, orphaned stars stripped from long-lost galaxies, and the ever-elusive dark matter that neither reflects nor absorbs light. This invisible matter forms the scaffolding on which the Milky Way is built, the skeleton that holds its spiral in shape. To find that skeleton smaller than expected challenges everything we know about how galaxies grow and survive. The Milky Way's shrunken halo also reshapes our understanding of cosmic evolution. A smaller halo suggests that our galaxy gathered less dark matter in its youth, which in turn limits the number of stars it could form. It may explain why our galaxy is less massive than Andromeda, why our spiral arms are tighter, and why the Milky Way's star formation is slowly fading. Even in cosmic architecture, size determines destiny. And yet, there's something humbling, almost tender, in realizing that the great invisible shell surrounding us is more compact than imagined. It reminds us that grandeur isn't a matter of size, but of intricacy. Our galaxy's halo may be smaller, but it's rich with history, a museum of collisions, mergers, and lost companions that shaped who we are today. So, the next time you look at the Milky Way and see that soft river of light across the sky, remember this. What surrounds it isn't emptiness, but a quiet halo of memory. It may be smaller than we thought, but within that unseen border lies the entire story of how our home in the cosmos came to be. For centuries, the night sky fooled us into believing we lived at the center of something grand. Now, computer simulations show the opposite. We occupy the thin outskirts of a galaxy adrift on the edge of a cosmic sea. When early astronomers first looked up, the Milky Way seemed to wrap around the heavens, endless and complete. The ancients saw it as the spine of the cosmos, a bridge between worlds, a luminous river of creation itself. Even when science replaced myth, a quiet pride remained, the comforting idea that our solar system must lie near the heart of this magnificent structure. But as our instruments evolved, that illusion began to fade. We are not near the center of anything. We are, in truth, drifting near the edge, a small star system in a quiet corner far from the galactic core. The Sun lies about 27,000 light-years from the Milky Way center, perched on one of its minor spiral arms known as the Orion Arm. It's not even a main arm, just a faint bridge between two larger ones. Around us, the galaxy stretches outward in all directions, yet the densest, brightest regions are far away, glowing faintly through the haze of interstellar dust. To see them clearly, we rely on the precision of our telescopes and the patience of centuries of observation. And what those views reveal is humbling. From where we stand, we are not at the heart of grandeur, but at its edge. Computer models of galactic motion confirm this truth. The Milky Way's stars swirl around the center in a flat rotating disk, and we are merely one small speck circling far from the middle, traveling at nearly 220 kilometers per second. To imagine we occupy a special place is to mistake perspective for privilege. The night sky appears to encircle us not because we stand at the center, but because we see from within. Every horizon feels central when it's all you know. The illusion of centrality is an ancient one, not just in astronomy, but in human nature. Once, we believed the Earth sat at the center of creation, with the sun, moon, and stars orbiting around us. Later, we placed our sun at the center of the universe. Then, when we discovered galaxies beyond our own, we imagined the Milky Way as a keystone among them. Each revelation pulled us further from the middle, yet closer to the truth. The universe has no single heart. It expands in all directions equally, with no favored point of origin. Every location, from the densest cluster to the loneliest void, is as central or as peripheral as any other. And still, that truth carries a quiet grace. To exist on the outskirts is not to be insignificant. It means we dwell where the galaxy thins, where the view of the universe beyond is clearest. From this edge, we can see farther into the cosmic dark than any world near the galactic core ever could. The illusion of importance fades, but in its place rises something better: perspective. We are not at the center of the Milky Way, nor the universe, nor perhaps anything at all. But from this fragile vantage on the edge of everything, we can see the grand design unfolding, a reminder that sometimes the best view of infinity comes from standing humbly at its border. Every star, planet, and nebula is trapped within the Milky Way's gravity well, a boundary that defines where our galaxy ends and intergalactic space begins. The shocking revelation: that border lies much closer than anyone thought. We tend to imagine our galaxy as boundless, its influence stretching far beyond the reach of light. But gravity, the quiet architect of all structure, draws the true borders of the Milky Way. It is gravity that holds the stars in orbit, that anchors the sun as it circles the galactic center, and that keeps countless worlds tethered to invisible paths through the dark. Every atom of our existence moves within that gravitational field, an unseen ocean that defines the shape of everything we know. Yet even this ocean has a shore, and we have just discovered how near it truly is. Astronomers once believed the Milky Way's gravitational reach extended almost indefinitely, its pull strong enough to influence objects hundreds of thousands of light-years away. But recent studies using precise stellar motion data from the Gaia mission have redefined that scale. The new models show that the boundary of our galaxy, the edge where its gravity weakens and space begins to belong to no one, may be as close as 100,000 light-years from the center, perhaps even less. Beyond that invisible frontier, the pull of the Milky Way fades and the intergalactic void begins. This region, sometimes called the galactic virial radius, marks the true end of our domain. Inside it, every star dances to the rhythm of the Milky Way's gravity. Outside it, they drift freely, untethered, caught between galaxies. It is a border without walls or light, defined not by what we see but by what we feel, a fading heartbeat in the fabric of space-time. To imagine this is to realize how small our home truly is. Within this invisible cage lies everything we've ever known. The sun, the planets, the Orion Arm, the glowing nebulae and clusters that decorate the sky. Even the farthest star visible to the naked eye lies deep inside this cosmic boundary. And yet, just beyond it, emptiness reigns. A silence so deep that even gravity begins to lose its voice. It's humbling to think that our galaxy, this magnificent spiral of light, exists in a kind of delicate balance. Its gravity binds billions of stars together, but only barely. Each outer star orbits at the edge of escape, held by forces so faint they're almost whispers. A single close encounter with another galaxy could send them adrift forever, lost to the endless night. And still, that fragile boundary is what makes the Milky Way whole. It defines the difference between belonging and drifting, between the gravity that holds and the freedom that consumes. We live within that balance, bound yet unbroken, free yet never truly alone. Perhaps that is the quiet beauty of gravity's cage. It doesn't confine us, it connects us. It draws the stars into harmony, the planets into motion, and our hearts into wonder. Without it, the universe would be chaos. With it, even the smallest galaxy becomes a home. Our Milky Way doesn't drift alone. It shares its corner of space with over 50 smaller galaxies, all caught in a slow dance around the massive Andromeda galaxy, a dance that will one day end in collision. From a human perspective, the night sky feels empty, silent, and still. But when seen through the lens of cosmic time, everything is in motion, a slow, graceful ballet spanning millions of light-years. The Milky Way is just one dancer in this vast performance, moving alongside its companions in what astronomers call the local group. It is not a cluster of stars, but of entire galaxies, bound together by the invisible thread of gravity. At the heart of this group are two great spirals, the Milky Way and Andromeda. They dominate the region like twin titans, their masses shaping the orbits of smaller companions around them. Between them drift dozens of dwarf galaxies, faint smudges of starlight that orbit and weave between the giants, like sparks caught in a magnetic field. The large and small Magellanic Clouds, visible from the southern hemisphere, are among these companions, circling the Milky Way in long looping paths. Others, like M32 and M110, cling to Andromeda's edges, small but enduring. The local group spans about 10 million light-years across, a small region compared to the vast superclusters beyond, yet immense beyond imagination to us. Within this volume of space, gravity holds each galaxy in a delicate balance. neither colliding too soon nor drifting away entirely. But the balance won't last forever. The Milky Way and Andromeda are slowly falling toward each other, closing the gap at a rate of about 110 kilometers per second. In roughly 4 billion years, the two will meet. That meeting won't be a sudden crash, but a slow merging, two galaxies passing through one another. Their stars mostly avoiding collision, but their shapes tearing apart and reforming over eons. Simulations show that when this happens, the skies of any surviving world will blaze with thousands of new stars as tidal forces trigger waves of creation. The Milky Way and Andromeda will become one, a new, larger galaxy that astronomers already call Milky Way. The local group will no longer be a gathering of two great spirals, but one unified structure shining even brighter. And yet, even as these cosmic events loom far in the future, there's comfort in knowing that our galaxy is not adrift in solitude. We are part of a community, a family of galaxies moving together through the cosmic web. Each exerts its influence on the others, not through noise or light, but through the quiet persistence of gravity. It's a connection so vast and gentle that it feels almost spiritual, a reminder that even in the emptiest stretches of space, nothing truly travels alone. From the edge of the Milky Way, if you could see the local group in full, it would appear like a scattering of faint embers across an infinite black sea. Each one glows softly, carrying its own history, its own story, and together, they drift, not as strangers, but as companions, moving slowly toward a shared destiny written in the language of gravity and time. Every second, the Andromeda Galaxy moves closer to us, pulled by the same gravity that defines our shrinking domain. In 4 billion years, the two will merge, forming a new, larger galaxy, one that erases the Milky Way entirely. Across the darkness, Andromeda shines like a faint smudge in the constellation of the same name, the farthest object visible to the naked eye. To look at it is to look at the future. That soft blur of light, 2.5 million light-years away, is not a stranger, it's a destination. Each moment, it draws nearer, its gravity intertwined with ours in a slow cosmic embrace that has been unfolding since the earliest ages of time. The approach of Andromeda is not fast by human standards, but relentless. The galaxies are converging at a rate of roughly 110 kilometers per second, fast enough to cross the distance between Manila and Tokyo in under a minute, but glacially slow across cosmic distances. For billions of years, they've been circling each other, pulled together by the same gravitational thread that holds the local group in place. And now, their paths are locked. Nothing can stop what comes next. When Andromeda and the Milky Way finally meet, they won't collide like two solid objects. Galaxies are mostly empty space, vast expanses of light and dust, separated by unimaginable distances. Instead, their meeting will be an intricate dance. Stars will weave between one another like fireflies in the dark, their motions reshaping both galaxies into one. Some stars will be flung outward into intergalactic space, forming long tidal tails that stretch for hundreds of thousands of light-years. Others will spiral inward, collapsing into new regions of star formation. For a time, the night skies of any surviving world will glow with unthinkable beauty. Great arcs of starlight stretching from horizon to horizon, two galaxies blending into one luminous storm. Eventually, the chaos will settle. The graceful spirals of both galaxies will dissolve, giving birth to a new elliptical form, a single massive galaxy with a calm, bright core. Astronomers call it Milky Way, the child of two cosmic giants. By then, our sun will be long gone, its light extinguished, but other stars will take its place, orbiting in new patterns, their worlds circling beneath alien skies. The Milky Way will no longer exist, not as we know it. It will live on only as a memory folded into something greater. This is not destruction, it's transformation. Galaxies grow through collision, through merging, through chaos turned into structure. Every star that survives will carry the story of two galaxies becoming one, proof that even endings can be beginnings on cosmic scales. And as we look up tonight, that faint smear of light in the sky is already telling us the story of what's to come. The Andromeda Galaxy is approaching, silently, gracefully, drawn toward us by the same gravity that holds the stars in their orbits and the Earth beneath our feet. It is a meeting written in the laws of physics, a reunion long foretold. The Milky Way's final act has already begun, not in fire or destruction, but in the slow, inevitable beauty of convergence. Dozens of tiny satellite galaxies orbit our own, many so faint they were invisible until recently. These ghostly companions reveal the true size of our gravitational influence, smaller than ever estimated. For much of history, we believed the Milky Way was alone, a solitary spiral adrift in an empty sea. But as our telescopes grew more sensitive, we began to notice faint smudges of light moving in step with our galaxy. They were not distant stars or background galaxies, but small companions, each one bound to us by gravity's delicate tether. Some are little more than collections of a few million stars, fragile clusters adrift in the halo of the Milky Way. These are the satellite galaxies, our forgotten neighbours, remnants of a more chaotic cosmic past. Among the brightest of these are the Large and Small Magellanic Clouds, two irregular galaxies visible from the southern hemisphere. They dance around the Milky Way in slow, looping orbits, their gas and stars stretched by our gravitational pull. Streams of material flow between them and our galaxy, forming luminous trails that glow faintly in ultraviolet light. But beyond these two well-known companions, dozens of smaller, darker satellites remain, galaxies so dim they were invisible until modern sky surveys revealed them. Some, like Segway 1 or Bootes 2, are so faint they blur the line between galaxy and star cluster. They are the faintest known galaxies in the universe, barely holding themselves together. These companions tell a story not just of what surrounds us, but of what defines us. Their motions reveal the limits of our galaxy's gravitational reach, the true extent of the Milky Way's domain. By tracing their orbits, astronomers can map the boundaries of our dark matter halo, the invisible sphere that binds everything together. And that map is smaller than we once believed. Many of these faint satellites orbit closer than expected, suggesting that our gravitational influence fades far sooner than models once predicted. The Milky Way, once thought to dominate a vast region of space, may rule over a smaller, denser realm. But these satellites are more than just markers of size. They are survivors, the remnants of galaxies long ago torn apart and consumed. Some of their stars once belonged to other systems, shredded by the Milky Way's gravity and absorbed into its halo. Each faint galaxy is a fossil of cosmic cannibalism, a clue to how our own galaxy grew. When astronomers study their chemical compositions, they find signatures of ancient collisions, evidence of a time when the Milky Way was young and hungry. Today, most of these companions live quiet, ghost-like lives, slowly orbiting in the dark. Some are already unraveling, their stars pulled into faint streams that circle the galaxy like cosmic scars. Over billions of years, they will disappear entirely, merging into the Milky Way's outskirts until no trace remains. And yet, their presence changes everything. These dim, elusive galaxies remind us that the Milky Way's greatness is not measured in size or brightness, but in connection. Each companion, no matter how small, is part of a greater system, bound by invisible gravity and shared history. We often picture the galaxy as a lone spiral in the dark, but in truth, it is surrounded by family, ancient, faint, and nearly forgotten. They orbit in silence, their light too weak for human eyes to see, but their influence shapes our galaxy still. Like quiet memories circling the edge of consciousness, these companions remind us that even in the vastness of space, nothing exists in complete isolation. As astronomers measured the outer halo, they expected to find distant, wandering stars marking the edge. Instead, they found emptiness. The Milky Way simply fades into darkness, its light vanishing far sooner than models predicted. For years, the image of our galaxy extended far into the night, a grand spiral surrounded by an endless haze of scattered stars. it was comforting to believe that even in its most distant reaches, the Milky Way still glowed faintly, its presence stretching on without end. But when scientists finally looked with precision, the illusion dissolved. No faint star clusters, no drifting remnants, only silence and void. Our galaxy, it seems, ends not with a flourish, but with a fade. Using the Gaia spacecraft and deep field surveys, astronomers traced the movement of stars across the galactic halo, the invisible sphere surrounding the Milky Way. They expected to find a gradual thinning, a slow decline in star density extending hundreds of thousands of light years into the dark. Instead, the data revealed an abrupt drop. Beyond about 100,000 light years from the center, the number of stars plummets. The halo's once imagined grandeur is smaller, denser, and sharply defined. The Milky Way does not dissolve endlessly into the void, it stops. This discovery changes the way we picture our galaxy. What once seemed infinite is now finite, a luminous island floating in a sea so deep that even light seems reluctant to cross it. The space beyond is not filled with hidden stars, but with dark matter, gas, and ancient debris. It's a quiet borderland where the last whispers of starlight are swallowed by cosmic night. There is something deeply haunting about that realization. To know that our galaxy ends abruptly, that its stars simply give way to emptiness, feels almost poetic. It mirrors the way human curiosity pushes outward, only to find the limits of what can be known. The universe, vast as it is, has edges of perception. The Milky Way's outer rim is one of them, a threshold where visibility collapses into mystery. And yet, the absence of light does not mean the absence of meaning. The darkness beyond the halo is not dead space, but the foundation of cosmic architecture. It is there that the gravitational pull of neighboring galaxies begins to take over. It is there that the Milky Way's influence ends and the universe's shared gravity begins. The edge of our galaxy is not a wall, it's a meeting place, where one domain gives way to another. Astronomers describe this quiet frontier in mathematical terms, but to the imagination, it feels like standing at the shoreline of existence, where the last grains of sand fall away and the ocean begins. Beyond this point, the light of our stars no longer rules. What lies there is not emptiness, but potential, the untouched, unlit canvas of the universe itself. In the end, the Milky Way's fading edge is not a failure of light, but a reminder of perspective. Every galaxy ends somewhere. Every glow gives way to silence. And maybe that silence isn't a void at all, but the beginning of something we have yet to see. Between the stars lies a thin mist of rogue planets and orphaned suns, ejected long ago. They drift through the darkness, reminders that our galaxy is constantly losing pieces of itself to the void. We often imagine the Milky Way as a harmonious system, billions of stars orbiting in unison, bound together by gravity's graceful hand. But beneath that calm rhythm lies a quiet chaos. Stars are born, live, and die in constant motion, and not all of them stay. Some are thrown away, cast adrift into interstellar space, untethered from any home. These are the ghosts of our galaxy, lonely wanderers drifting between the stars, their light faint, their journeys eternal. Astronomers call them rogue objects, stars, planets, and even brown dwarfs that have been ejected from their systems through violent gravitational encounters. A close pass between two stars, or the explosion of a massive supernova, can fling worlds and suns outward at incredible speeds. Over billions of years, these expulsions accumulate. It's estimated that for every star still bound to the Milky Way, there may be several planets that roam freely in the dark, their skies forever empty. Recent observations from the Nancy Grace Roman Telescope and gravitational microlensing surveys have begun to uncover evidence of these lost worlds. Planets the size of Jupiter, Neptune, even Earth, drifting through space without a parent star. They are invisible in ordinary light, detectable only when their gravity bends and magnifies the light of a distant background star. Each detection is like finding a pebble in the ocean, proof that the void between stars is not truly empty, but filled with hidden wanderers. And stars, too, can be exiled. Some move faster than any galaxy could hold, hurled outward by encounters with the supermassive black hole at the Milky Way center. These hypervelocity stars streak across intergalactic space, glowing faintly as they race towards solitude. Others drift slowly, cooling over eons until their light fades completely. They are the uncounted dead, the forgotten citizens of a galaxy that never stops losing its own. This slow unraveling is not a flaw, but a feature of cosmic evolution. Galaxies breathe, they take in and give back to the universe. Some of our lost stars will be captured by neighboring galaxies, others will remain forever alone, silent witnesses to the passing of cosmic time. Their existence reminds us that the Milky Way is not a static structure, but a living, changing organism, constantly reshaped by motion, chance, and gravity. When we look up at the night sky, we see only the stars that remain, the ones still bound to us. But scattered between them, in the vast blackness our eyes can't see, drift countless others, unseen yet no less real. Planets without dawns, suns without warmth, travelers without destinations. And perhaps, somewhere out there in that darkness, a lost world still carries echoes of a sky that once looked like ours, the faint memory of a galaxy it can no longer return to. The Milky Way sheds these fragments into the deep, not in tragedy, but in quiet inevitability. For even galaxies must let go, piece by piece, as they move through eternity. Dark matter, once believed to make up most of our galaxy's mass, may be distributed far more thinly than thought. The Milky Way might not be as heavy or as gravitationally powerful as we assumed. For decades, scientists spoke of dark matter as the invisible glue holding the universe together. Though it cannot be seen or touched, its gravitational fingerprints are everywhere, in the way galaxies spin, in the motion of stars, in the large-scale web of cosmic structure. The Milky Way, too, was thought to be surrounded by a massive halo of this unseen substance, outweighing all its stars and gas by a factor of 10. But in recent years, that certainty has begun to waver. As instruments have grown more precise, the numbers no longer add up. Our galaxy's invisible mass may be far lighter than we once imagined. Astronomers have long measured dark matter's influence indirectly by studying how stars move. The faster they orbit the galactic center, the more gravity, and therefore mass, must be present to hold them in place. For years, those orbital speeds suggested a vast reservoir of dark matter enveloping the Milky Way. But when new surveys from Gaia began mapping star motions with unprecedented accuracy, the results painted a subtler picture. The outermost stars aren't moving as fast as expected. The invisible hand guiding their motion seems weaker, the gravitational pull softer. This means our galaxy may contain far less dark matter than once believed. Some estimates suggest the Milky Way's total mass could be only half, or even a third of earlier calculations. In the cosmic hierarchy that shifts us downward, from a heavyweight spiral to something smaller, quieter, more fragile, even our place within the local group changes. Andromeda, it turns out, might outweigh us by nearly double. The realization is both humbling and profound. For years we assumed the Milky Way's invisible skeleton was massive and dominant, the unseen foundation of all we see. But what if our galaxy's strength lies not in hidden mass, but in balance? A lighter halo might explain why our spiral arms are tighter, why our edges fade so abruptly, and why nearby galaxies can tug at us more easily than expected. In a universe defined by gravity, to be lighter is to be more vulnerable, and yet, perhaps, more dynamic. Dark matter itself remains one of science's greatest mysteries. We still don't know what it is, whether it's made of exotic particles, quantum fields, or something stranger still. But by studying how little of it we have, astronomers learn more about how galaxies form, evolve, and fade. Every adjustment, every remeasured motion, reshapes our understanding of the universe's invisible architecture. It's a strange paradox that the more we learn about what's missing, the clearer the picture becomes. Our galaxy might be lighter than expected, its gravity weaker, its boundaries nearer, but in that lightness, there's a kind of grace. We exist within a delicate structure that holds together not through brute force, but through perfect tension. The fragile equilibrium between light and dark, seen and unseen. The Milky Way's true weight, it seems, isn't measured in stars or matter, but in the mystery it carries, the weight of nothing, shaping everything. There is no visible wall marking the end of the Milky Way, only a gradual fading, like the edge of a cloud. Our galaxy's boundary is not a line, but a whisper between starlight and silence. When we picture a galaxy, we imagine something defined, a clear spiral, its arms curving outward in a perfect pattern, its borders distinct. But the universe doesn't deal in edges, it deals in gradients. The Milky Way doesn't end abruptly, it dissolves. The stars thin out, their light scattering through fields of dust and dark matter, until the glow fades into the cosmic background. There's no moment when the galaxy stops and the void begins, only a soft transition, a slow quieting of light into darkness. Astronomers once searched for the galaxy's perimeter, expecting to find some kind of visible boundary, a rim, a final layer of stars marking the outermost edge. But even the most sensitive telescopes, peering tens of thousands of light years into the dark, saw no wall, no cutoff. Instead, the Milky Way behaves like a mist drifting through a breeze, its particles spread thinner and thinner until they blend into the unseen. This revelation changes how we define where we belong. The galaxy isn't a structure confined by borders, but a living continuum. Every star exists within an invisible gradient of belonging, pulled by gravity, shaped by motion, and balanced between light and nothingness. Even the space between galaxies isn't truly empty. It's filled with faint traces of gas, magnetic fields, and the quiet tug of dark matter. The boundary between us and the rest of the universe is not a frontier, but a blur. In this way, the Milky Way mirrors nature itself. There are no sharp edges in reality, only transitions. Mountains fade into plains, oceans blend into air. Life shades imperceptibly into death. The cosmos follows the same rhythm, everything connected by gradients too subtle for human eyes to see. Our galaxy's edge is not an end, but a suggestion, a whisper of where one influence yields to another. And perhaps that's why the Milky Way feels so infinite when we gaze upon it. The absence of borders allows our imagination to wander freely. We can look into its haze and believe that it stretches forever, because our minds, too, resist boundaries. In a universe without edges, every direction feels like the beginning of something new. Scientists describe the outermost stars as unbound, no longer held tightly by the galaxy's gravity, yet still tracing faint arcs through its influence. They drift in liminal space, not quite part of the Milky Way, not yet lost to the void. These are the galaxy's wanderers, its final notes before silence. To stand beneath the night sky is to witness this boundary firsthand. The Milky Way arches overhead, glowing softly, and somewhere within that glow, the light fades, unnoticed, invisible but real. It is the most delicate of endings, one that doesn't separate but unites. The edge that isn't there reminds us that endings and beginnings are the same thing seen from different sides. The Milky Way doesn't stop, it simply fades into the greater whole, just as we do. If the Milky Way were the size of a single grain of sand, the entire observable universe would stretch from here to the edge of the Pacific Ocean. Our galaxy, once thought infinite, is just a flicker in an ocean of light. Numbers fail when faced with scales like this. 100,000 light-years across, that's the Milky Way's diameter, a distance so large it bends comprehension. Yet when compared to the universe, that span becomes almost nothing. The observable cosmos stretches more than 90 billion light-years in every direction, a sphere so vast it could swallow our galaxy countless times over. We live inside something too large for language to capture, and too intricate for the mind to fully contain. Astronomers often use metaphors to bridge the gap between comprehension and scale. If the Milky Way were a single grain of sand, then the Andromeda Galaxy would be another grain just a few inches away. Between them, smaller flecks, the dwarf galaxies of the local group, would drift like dust. And around them, trillions of other grains, scattered across a beach that stretches beyond any horizon. Every point of light in the sky, every distant smudge seen through a telescope, would be another grain resting beside ours, and beyond that, still more, extending into the dark like the foam of an eternal sea. For much of history, we believed our galaxy was the universe, a grand, self-contained cosmos. Then, in the early 20th century, astronomers like Edwin Hubble peered deeper and discovered that the faint nebulae dotting the sky were not clouds within our galaxy, but entire galaxies themselves, each containing billions of suns. In that moment, our perception of reality expanded beyond all measure. The Milky Way, once everything, became a single voice in a choir too vast to count. Today, computer simulations reveal that the universe holds roughly 2 trillion galaxies. Each one a city of stars, each one perhaps with its own planets, its own chemistry, its own quiet chances at life. The Milky Way, immense to us, infinite to the naked eye, is just one spark among trillions. And yet, that spark matters, because within it lies something rare. Awareness. The ability to look outward and measure our own smallness, to turn insignificance into wonder. Scale doesn't diminish meaning, it gives it context. If anything, the vastness of the universe amplifies our presence, showing how extraordinary it is that we can even comprehend a fraction of it. To gaze at the night sky is to stand at the edge of infinity and hold a grain of it in your mind. We are beings made of stardust, observing the stars, tiny fragments of a galaxy that itself is tiny within the whole. The universe may stretch beyond our reach, but through thought, through curiosity, we touch it. The Milky Way is a spark, yes, a brief shimmer in a cosmic ocean. But sometimes, one spark is enough to illuminate everything. At the heart of the Milky Way lies Sagittarius A star, a supermassive black hole. For decades, we believed it ruled a vast empire of stars. Now we know, its kingdom is smaller, its subjects fewer. In the silent center of our galaxy, 40,000 light-years away, there is a region where light itself cannot escape. Sagittarius A asterisk, pronounced A star, sits there like a cosmic heartbeat, invisible yet powerful, a well of gravity so deep that anything crossing its threshold is lost forever. For most of modern astronomy, it was assumed to be the master of a sprawling domain, controlling the motion of countless stars through sheer gravitational might. But new measurements have humbled even this titan. Its reach, while immense, does not stretch as far as we once imagined. For decades, the image of the Milky Way's core was one of dominance, a blazing hub of billions of stars swirling around an all-consuming black hole. But as the Event Horizon Telescope and infrared observatories peered deeper into the center, a subtler picture emerged. The region directly influenced by Sagittarius A asterisk, the volume where its gravity truly commands, spans only a few light-years. Beyond that, the pull of the galaxy's collective mass takes over. The black hole, once thought to rule an empire, is merely the anchor of a vast system held together by the shared gravity of stars, gas, and dark matter. Even so, its influence is profound. The stars that orbit closest to Sagittarius, A asterisk, known as the stars, move at unimaginable speeds, some traveling thousands of kilometers per second. Observing them over decades has allowed astronomers to confirm Einstein's theory of general relativity with exquisite precision. Time itself bends near the core, space curves like fabric drawn tight, and light reddens as it tries to climb away. These stars are silent witnesses to the most extreme conditions our galaxy can offer. Tiny messengers, circling a darkness that defines their motion, but not their fate. Sagittarius A times weighs about 4 million times as much as our Sun, massive enough to warp the space around it, yet small compared to the behemoths found in other galaxies. Some black holes in the universe are 1,000 times larger, with gravitational spheres spanning entire solar systems. By comparison, our galactic center is almost modest, its quiet power a reflection of the Milky Way's overall humility among the cosmos. Yet, from that modest heart radiates meaning. Sagittarius A, times is both an ending and a beginning, a place where matter dies and, in its fall, fuels creation. The black hole's magnetic storms and energetic flares shape the surrounding gas, influencing how stars are born in the central bulge. Even destruction becomes part of the galaxy's rhythm. When astronomers captured the first image of Sagittarius A times in the 2020s, a blurry ring of light surrounding darkness, it was more than a technical achievement, it was a mirror. That faint, glowing halo, light bent by gravity and time, reflected the story of our home. Vast, complex, but bound by something deeper than light, by gravity, by motion, by continuity. We once believed the galactic core was the throne of a cosmic ruler. Now we understand it as something more subtle, more profound, a balancing point. Not the seat of power, but the still center of a living spiral. Every orbit, every rotation, every flicker of light across the Milky Way is, in some way, connected to this quiet singularity at its heart. Black holes once thought to populate every corner of our galaxy appear rarer than expected. The Milky Way's population of hidden monsters has thinned, suggesting we may be a quieter galaxy than our neighbors. For decades, scientists imagined our galaxy as a place filled with invisible predators. Tens of millions of black holes left behind by long-dead stars, scattered like dark embers through the spiral arms. They were the unseen legacy of supernovae, the quiet aftermath of stellar death. And for a time, the numbers seemed to confirm this. Every massive star, it was believed, would one day collapse under its own gravity, adding another black hole to the growing census. But as our instruments improved, the expected abundance never appeared. The Milky Way, it seems, is not as crowded with these silent giants as we once thought. Modern observatories such as Gaia, Chandra, and the Very Large Telescope have helped astronomers peer into the dark with unprecedented precision. By tracking the motion of stars that appear to orbit nothing, scientists can detect the presence of hidden black holes. Each discovery adds a new data point to our understanding of how common they truly are. What we've found so far is surprising. Where models predicted millions of stellar mass black holes, we've detected only a fraction of that number. The galaxy is quieter, more restrained, and more orderly than the chaos we once envisioned. This doesn't mean the monsters are gone, only that they are fewer, or perhaps sleeping. Some may drift through the halo unseen, their gravitational pull too subtle to betray them. Others might exist in binary systems, locked in a delicate dance with a companion star, siphoning gas and glowing faintly in X-rays. But the absence of countless black holes implies that the Milky Way has lived a gentler life than its more violent peers. We have not endured as many cataclysmic collisions or starburst eras that seed galaxies with dark remnants. Instead, our home has evolved with quiet dignity, a slow spiral of creation and decay, not a storm. Even the central black hole, Sagittarius A*, rests in unusual calm. Many galactic centers blaze with radiation as their supermassive black holes feast on gas and dust, becoming quasars visible across billions of light years. Ours, by contrast, barely glows. It flickers occasionally, a soft pulse, a brief flare, but spends most of its existence in tranquil silence. In an age of cosmic violence, we live in a subdued neighborhood. And perhaps that calm is what made life possible. A more violent galaxy filled with roaring quasars and frequent supernovae might have sterilized its worlds long before consciousness arose. The Milky Way's stillness, its long, unbroken stretches of stability, gave our sun time to form, our Earth time to cool, and our species time to look up. The quiet giants of our galaxy may be few, but their silence speaks volumes. They are the unseen witnesses of time, remnants of destruction that now rest in peace. And their scarcity tells a story not of absence, but of balance. a galaxy that has learned to endure without excess, to grow without consuming itself. So when you look at the stars tonight, remember that beneath that calm sky, black holes still drift, sleeping giants in an ocean of light. But unlike the violent galaxies that burn too brightly and fade too soon, ours hums softly, steadily, like a lullaby sung across the ages. High-precision mapping reveals that the Milky Way's disk is only about 1 to 100,000 light-years across, smaller than most spiral galaxies of its kind. What we call vast is, on a cosmic scale, modest. For centuries, the Milky Way represented the pinnacle of grandeur. It was our symbol of immensity, the measure against which we compared everything else. To imagine it shrinking feels almost personal, as though the universe itself were humbling us. Yet the latest data paints exactly that picture. Our galaxy, magnificent as it seems from within, is smaller than most of its spiral neighbours. The vast ocean of stars we once called infinite turns out to be a gentle sea, wide enough to inspire awe, but far from boundless. Astronomers once estimated the Milky Way's diameter at nearly 200,000 light-years, its spiral arms stretching endlessly into the void. But as technology refined our cosmic vision, those numbers began to contract. The Gaia mission's three-dimensional maps, combined with radio surveys tracing hydrogen gas and molecular clouds, have redrawn the outlines of our home. What was once thought to be a grand, sprawling spiral is now revealed as compact, about 1 to 100,000 light-years across, with the disk thinning into darkness at the edges far sooner than imagined. In the vast catalogue of galaxies, this makes us modest. The Andromeda Galaxy, our nearest neighbour, spans nearly twice our diameter. Other spirals, like the massive UGC 2885, sometimes called the Godzilla Galaxy, are several times larger still, their arms sweeping across 500,000 light-years. By comparison, the Milky Way is a quieter, denser, and more reserved structure, a masterpiece of precision rather than scale. But smallness does not mean insignificance. If anything, it grants us a clearer view of the universe beyond. Our galaxy's compact form allows its outer edges to fade cleanly into the intergalactic dark, giving us windows through which telescopes can glimpse the larger cosmos. Because we are not buried deep within a massive spiral, we can see beyond our own boundaries more easily. Our galaxy's modest size has made it one of the best vantage points for understanding everything else. Even within the Milky Way's disk, the story of contraction continues. Its spiral arms are tighter than we once believed, coiling close to the centre in elegant symmetry. Some astronomers suggest that over billions of years, the galaxy may be slowly shrinking further, not through loss, but through evolution. As stars age and die, and as new ones form closer to the core, the luminous part of the galaxy becomes more compact, its light gathering inward like a deepening breath. The more we measure, the smaller we become, and the greater our wonder grows. What we lose in imagined scale, we gain in understanding. To know that the Milky Way is small among galaxies does not make it less extraordinary. It makes it personal. It means that within this relatively modest spiral, on a small world orbiting a minor star, consciousness arose and began to measure the universe itself. In that realization lies a quiet poetry. We are small, yes, but so is our home. And somehow, from this tiny corner of a shrinking spiral, we have seen farther than the galaxy ever will. Simulations show that galaxies similar to ours often contain twice as many stars. Somewhere in our formation, something, perhaps a burst of radiation or a violent collision, stunted our growth. The Milky Way, magnificent though it appears, is not as full as it should be. For a galaxy of its type, a barred spiral with a calm central bulge, we are missing billions of stars. Models of galactic evolution suggest that the Milky Way should shine brighter, spin faster, and carry far more stellar mass than it does. Something long ago slowed our growth. Somewhere in our history, a moment came when our galaxy stopped becoming what it could have been. Astronomers have pieced together clues from stellar ages, chemical compositions, and orbital motions, and the evidence points toward disruption. Perhaps it was a collision billions of years ago with a smaller galaxy whose impact disturbed our disk and robbed us of gas, the raw material of new stars. Or perhaps it was a cosmic radiation event, a surge of energy from the early universe that stripped away our star-forming clouds. Whatever the cause, the effect remains etched across our structure. A galaxy quieter than its peers, its star factories dimmer, its spiral arms thinner. The Gaia Enceladus event, for example, is believed to have reshaped our galaxy around 10 billion years ago. A smaller galaxy collided with the young Milky Way, merging violently and scattering stars into the halo. This ancient crash disrupted our early evolution, slowing star formation for billions of years. Some astronomers even describe this era as a cosmic trauma, a wound that altered our destiny. Where other galaxies continued to flourish, building new generations of stars, ours entered a long, subdued recovery. And yet, there's beauty in this restraint. The stars we never had may have made room for something rarer, stability. A more massive, more active galaxy might have been too violent for fragile worlds to endure. With fewer supernovae and less turbulence, the Milky Way became a gentler place. Our sun, born in this quiet epoch, found a home where life could emerge undisturbed for billions of years. In losing brightness, the galaxy gained balance. The story of the Milky Way is not one of failure, but of adaptation. Like a tree that grew gnarled from storms, it found strength in its imperfections. The missing stars are not signs of weakness. They are the spaces that allowed complexity to arise. The universe doesn't reward size alone, it rewards endurance. Even now, our galaxy forms new stars, though at a slower pace. Clouds of hydrogen collapse under gravity's weight, birthing light where darkness once lingered. But the days of great stellar abundance are behind us. The Milky Way is entering middle age, steady, luminous, content with what it has become. So when we gaze at the sky and see its gentle glow, we are witnessing both what is and what could have been, the brilliance of survival over excess, the quiet triumph of a galaxy that grew not to dominate, but to endure. The Milky Way may have fewer stars than it was destined for, but perhaps that was never the point. Its beauty lies not in what it gained, but in what it chose to keep. Billions of years ago, the Milky Way collided with another galaxy. That impact left scars, warped arms, lost stars, and a shrunken core. We are living inside the aftermath of cosmic trauma. Long before the Sun was born, before Earth even existed, two galaxies met in the dark. The smaller of the two, a dense, ancient system now known as the Gaia Enceladus galaxy, fell into the Milky Way's gravity and struck it head-on. It wasn't a collision in the way we imagine. Stars are so far apart that few actually touched. Instead, their gravities interwove, tearing both galaxies apart from within. For hundreds of millions of years, they merged and mingled, their orbits unraveling into chaos. The Milky Way, once youthful and round, was reshaped, its once smooth halo stretched into streams, its disk twisted, its symmetry lost forever. What we see today, the elegant spiral arms, the tilted disk, the uneven halo, are the long faded bruises of that ancient impact. The Gaia mission, with its precise mapping of star motions, revealed the fossil record of this event written in motion itself. Among the billions of stars that make up the Milky Way, some move in the opposite direction, tracing orbits that defy the normal galactic flow. These are the survivors of the collision, the intruders from another galaxy, still spiraling through ours like echoes of a distant scream. The aftermath of that merger was transformative. The influx of energy and material heated our young disk, thickening it and halting star formation for eons. Much of the gas that could have birthed new suns was scattered into the halo or expelled entirely into intergalactic space. The Milky Way became quieter, dimmer, a galaxy recovering from its own violence. Its spiral arms, once broad and symmetrical, became warped and uneven, bending upward and downward like ripples frozen in time. Even the galactic core bears the mark of that trauma, smaller, denser, and more distorted than before. Astronomers often describe galaxies as living things, and in this case, the metaphor feels fitting. The Milky Way was wounded, reshaped, and forced to heal. Over billions of years, gravity smoothed the chaos, weaving the scattered stars into something new. The galaxy we see now, calm, luminous, and seemingly timeless, is the scar tissue of that recovery. The arms that dazzle us on clear nights are not pristine creations. They are the product of ruin and renewal, a delicate beauty born from destruction. And though that ancient collision has long ended, its effects ripple on. Streams of stars, remnants of the Gaia Enceladus system, still orbit our halo. Faint threads of light circling the galaxy like whispers from the past. Each one tells the same story, that even in the vastness of the cosmos, growth comes through collision, and peace follows after chaos. We often look at the Milky Way and see harmony, but hidden beneath that calm surface is memory, a reminder that beauty can be the consequence of trauma, and that even galaxies carry scars. Ours simply learned how to turn them into light. Even now, our stars move in subtle waves through the disk, echoes of that ancient collision, rippling like water after a stone's fall. These ripples help scientists measure the Milky Way's true smaller size. The Milky Way looks serene from afar, a quiet swirl of light frozen in space, but up close, it moves like something alive. The stars that make up its disk are not gliding smoothly in perfect circles. They rise and fall, shifting rhythmically as if breathing. These vertical oscillations, discovered only recently, are the lingering fingerprints of an ancient upheaval, the collision that forever changed our galaxy's form. The impact with the Gaia Enceladus galaxy billions of years ago didn't just warp our arms or distort our halo. It sent waves through the very structure of the Milky Way, waves that still travel through us today. When astronomers first mapped these ripples using Gaia's precise measurements of stellar motion, they were stunned. Stars on opposite sides of the galactic disk were moving up and down in coordinated patterns, like synchronized swimmers following an invisible rhythm. This was no random drift, it was the echo of a single, massive disturbance long past. Much like how seismologists study the vibrations of an earthquake to understand Earth's interior, astronomers realized they could use these galactic seismic waves to probe the structure of our home. By analyzing the amplitude and timing of the ripples, scientists could estimate the mass and thickness of the Milky Way's disk. What they found was unexpected. The disk was thinner and lighter than previous models suggested. The ripples revealed that our galaxy isn't as large as once thought. Its outermost stars orbit closer than earlier measurements implied, its edges more fragile, its depth more shallow. The Milky Way, though vast by any human measure, is far more compact than the grand spirals that dominate the cosmos. These waves move slowly, taking hundreds of millions of years to travel across the galaxy. As they pass, they subtly lift and lower entire regions of stars, gas, and dust, creating a pattern of motion we can only perceive through generations of observation. Even the Sun, and the Earth with it, rides one of these waves, gently bobbing above and below the galactic plane every 30 million years or so. We live, quite literally, on a ripple of memory. It's a haunting thought that the motion of every star in the sky is shaped by something that happened before our world existed. The night we look upon, calm, eternal, unchanging, is, in truth, still ringing from an ancient collision. The galaxy hasn't yet settled, it continues to breathe with the pulse of its past. In a way, these ripples make the Milky Way more human. They remind us that memory leaves marks not only in minds, but in matter. That even in the scale of galaxies, the past refuses to be forgotten. The scars of what once was become the structure of what is. We are part of a galaxy still in recovery, still trembling softly from a collision billions of years gone. And as we drift through those waves, we carry that history with us. Not as tragedy, but as proof that even the deepest disruptions can give rise to new harmony. When astronomers tallied the mass of visible stars, planets, and dust, something didn't add up. The galaxy's total mass was far lower than predicted. Somewhere, much of the Milky Way, simply isn't. It began as a mystery of arithmetic, a quiet contradiction that defied the laws of cosmic balance. For years, scientists believed they had a clear picture of our galaxy's weight, a mixture of luminous matter, dark matter, gas, and dust, all held together by gravity's invisible hand. But as the data improved, the sums stopped working. The motions of stars didn't match the expected pull of gravity. The halo wasn't as massive as models predicted. The numbers fell short by billions upon billions of solar masses. Somewhere, the Milky Way was missing nearly half of itself. At first, astronomers assumed the missing matter must be hidden, perhaps in the form of cold gas too diffuse to detect, or faint dwarf galaxies lurking at the edges of our reach. Others speculated that it might lie in the form of dark matter clumps, orbiting unseen like ghosts around the halo. But as surveys from the Gaia, Hubble, and Fermi observatories mapped the galaxy in exquisite detail, that explanation began to crumble. The faint glow of gas was accounted for. The dark matter halo was smaller than predicted. The satellites, though many, couldn't make up the difference. What vanished wasn't just invisible, it was unaccounted for. One of the leading theories suggests that the Milky Way simply lost much of its matter long ago. During its violent youth, when collisions and starbursts were frequent, powerful winds from supernovae and black hole activity may have blown huge amounts of gas out into intergalactic space. That material, the seeds of future stars, drifted away and never returned. Our galaxy, in essence, shed its own potential. The missing matter might still be out there, stretched thin between galaxies, forming a cosmic mist too faint to see. Another possibility is even stranger, that our models of how mass is distributed in galaxies might be incomplete. If gravity behaves differently at large scales than we think, or if dark matter interacts in ways we've yet to detect, then our entire understanding of what missing means may need to change. Perhaps the Milky Way isn't missing matter at all. Perhaps it was never as massive as we imagined. Either way, the revelation reshapes how we see our home. The Milky Way, once envisioned as a heavyweight among spirals, turns out to be lean, almost fragile. Its stars orbit with just enough gravitational pull to hold the structure together, no more, no less. It is balanced on a knife's edge between cohesion and collapse, a cosmic dance sustained by precision rather than power. And yet, there's something poetic about that lightness. The galaxy's missing matter isn't a loss to mourn, but a sign of survival. A leaner Milky Way may have burned less violently, lived more gently, and lasted longer than its brighter, heavier cousins. The universe often favors the delicate, the structures that endure because they expend less. So perhaps the missing matter isn't gone at all. Perhaps it simply became part of everything else, scattered through the universe like the faintest dust of existence, reminding us that what is unseen still shapes what remains. Streams of ancient stars snake through space, remnants of smaller galaxies devoured long ago. They trace the limits of our reach, revealing how far our gravity extends before fading into nothing. If you could see the Milky Way from afar, not in visible light, but through the lens of time, you would notice faint, luminous rivers wrapping around it. These are stellar streams, the remnants of galaxies and star clusters pulled apart and stretched thin by our gravity. Each one tells the story of something smaller that wandered too close, a companion galaxy, a cluster of stars, drawn in by the Milky Way's pull and slowly unraveled over billions of years. Their light now flows across the sky in delicate arcs, like the ghostly trails of comets frozen in eternity. The discovery of these streams began in the late 20th century, but it was the Gaia mission that revealed their true extent. With its ability to track the motions of more than 1 billion stars, Gaia uncovered dozens of rivers crossing the galactic halo, each one a fossil record of a past collision. The Sagittarius stream, for instance, stretches across the heavens, a ribbon of stars torn from the Sagittarius dwarf galaxy as it was devoured by the Milky Way. Others, like the Orphan stream and the GD1 stream, weave intricate paths through the dark, mapping the invisible shape of our galaxy's gravitational field. To astronomers, these streams are not just remnants, They are measuring tools. Their orbits trace the true boundary of the Milky Way's influence, outlining where our gravity weakens and the intergalactic void begins. The more precisely we follow their paths, the clearer our galaxy's shape becomes. And what those paths reveal is humbling. The Milky Way's reach ends closer than expected. Beyond a certain point, these stellar streams begin to unravel, their stars escaping into the deep, where the pull of other galaxies takes over. Each stream is a message from the past, a record of violence softened by time. What were once collisions are now elegant curves of light. These stars, scattered and wandering, no longer belong to any one home. Yet they remain bound by memory, their motion guided by the ghost of a galaxy that once was. In their faint glow, astronomers can read our history, every merger, every loss, every shift in the Milky Way's slow evolution. There's a quiet poetry in their existence. These rivers are the galaxy's scars, but they are also its art, graceful, shimmering reminders that even destruction can leave beauty behind. They show us that our galaxy is not static, but alive, always reshaping itself, always in motion. And perhaps, on a deeper level, they mirror us. We, too, are shaped by what we absorb, by the fragments of things long gone that continue to move within us. The Milky Way, like every living thing, carries its past not as a weight, but as motion, as light still flowing outward, tracing the invisible edges of its being. At the outermost reaches of these streams, the stars begin to fade. Beyond them, the night deepens into silence, and the Milky Way's presence dissolves into the intergalactic dark. That is where our galaxy ends, not in a border, but in a whisper, carried away by the slow, eternal current of the cosmos. Data from Gaia suggests our stellar halo may extend only 60,000 light-years from the center, far less than once believed. The Milky Way, once imagined as colossal, is now just average. For much of modern astronomy, we pictured our galaxy as enveloped in a vast, ethereal sphere of stars, a halo so immense that it reached hundreds of thousands of light-years into space. It was thought to be a glittering shell of ancient suns, faint but infinite, surrounding the Milky Way like a cosmic aura. This halo was more than a boundary. It was our claim to immensity. It said that we were not small, but sprawling, a galaxy of grandeur stretching into the dark. But Gaia, the patient watcher, has stripped away the illusion. Its data, drawn from the slow, precise motion of millions of distant stars, reveals a different story. The halo is there, yes, but it ends far sooner than we believed. The faint envelope of stellar light surrounding the Milky Way extends not 200,000 light-years, but closer to 60,000. Beyond that lies only emptiness, a silence where we once imagined stars. It's a revelation that reshapes our self-image. For decades, we compared our galaxy to giants, Andromeda, the Whirlpool, the Sombrero, believing ourselves their equal. Now we know the truth. We are modest, middle-sized, average in every measurable way. Our halo is smaller, our gravitational reach weaker, our mass lower. The Milky Way, it seems, is not the cosmic monarch we once envisioned, but one of many, an ordinary galaxy among countless others. Yet there is a quiet grace in that ordinariness. Within our smaller halo lies clarity, structure, and stability. A vast halo filled with ancient stars would have meant a more violent past, countless collisions, chaotic mergers, and turbulent growth. Our compact one suggests something gentler. The Milky Way has endured its share of cosmic storms, but it has also settled into a calm that few galaxies achieve. Its smaller halo is the sign of a survivor, not a failure. Astronomers studying the composition of this halo find that its stars are old, older than the galaxy's disk itself. They are relics from the Milky Way's infancy, remnants of the first galaxies it ever consumed. Some of these stars orbit in elongated loops, others drift aimlessly through the outskirts, like ancient travelers who never found their way home. Together, they mark the true boundary of our influence, the place where our galaxy's light fades and the universe begins. There's something humbling about learning that our home is not colossal, but common. It brings the universe closer, makes it more human. We don't live in an empire of light. We live in a small, intricate system, balanced between creation and quiet. The Milky Way doesn't need to be enormous to be extraordinary. Its beauty lies in its detail, its restraint, its subtlety. And so, the great halo we once imagined is gone, not lost, but redefined. What remains is a truer picture. A smaller galaxy, yes, but one that endures, one that still breathes and glows in the dark. In the end, perhaps being ordinary among the stars is the most extraordinary thing of all. Between the Milky Way and its nearest galactic neighbour lies 2.5 million light-years of near-perfect emptiness. For all our stars and worlds, we are still alone in a staggering void. We like to think of the universe as crowded, full of galaxies, stars, and swirling light. But even in this abundance, space is mostly nothing. The Milky Way and Andromeda may be locked in a slow gravitational embrace, destined to merge in billions of years, yet between them lies an expanse so vast, so desolate, that the human mind can scarcely grasp it. 2.5 million light-years, a gulf so wide that a beam of light, the fastest thing in existence, would take 25 centuries to cross it. Between our galaxies stretch oceans of darkness, thinner than thought, lonelier than silence. In that void, the average density of matter is almost zero. For every cubic meter of space, there may be only a few stray atoms, remnants of cosmic gas or the faint dust from ancient collisions. No light travels there unless it comes from distant stars, no planets orbit, no warmth lingers. It is the great between, the intergalactic desert that defines our cosmic isolation. Astronomers call this region the intergalactic medium, a nearly invisible mist that threads between galaxies. It is the connective tissue of the cosmos, yet it feels like absence itself. To cross it would be to drift through nothingness for millions of years, with only the faint background glow of the Big Bang to keep you company. Even photons, those tireless travellers, wander through it for eons before finding another home. The scale of this solitude is humbling. Every star we see, every sunrise, every spark of life exists within the Milky Way's boundaries. Beyond them lies a silence untouched since time began. We live inside one luminous island surrounded by infinite dark sea, and no bridge connects us to the next shore. It is a reminder that space is not just vast, it is profoundly empty. Yet within that emptiness, there is something sacred. The distance between galaxies is not merely isolation, it is protection. The quiet between them gives structure to the universe, allows galaxies to form, evolve, and breathe without interference. Without the void, there would be chaos. The space between is what allows anything to exist at all. Still, it's haunting to think that our entire civilization, every memory, every discovery, every dream, occupies a speck of light adrift in a sea of nothing. Between us and the next nearest civilization, if any exist, lie distances so immense that communication itself becomes impossible. Even if another intelligent species looked our way tonight, the light they'd see would be ancient, a glimpse of our world long before humans ever looked back. In the stillness of that realization lies a strange peace. We are small, yes, impossibly so, but we are also luminous. Against the vast indifferent dark, the Milky Way glows like a candle in an endless night. And though we are alone in this moment, that light, fragile and brief as it may be, is proof that solitude does not mean silence. We are the voice of a galaxy surrounded by nothing, and somehow that makes our whisper all the more precious. In galactic rankings, the Milky Way doesn't even make the top 10. Dozens of spirals larger and brighter fill the cosmos. Yet, somehow, this humble swirl of light became home to conscious life. In the grand census of the universe, the Milky Way is not a standout. It is not the largest, nor the brightest, nor even the most beautiful by astronomical standards. Galaxies like IC 1101, the massive elliptical stretching over 6 million light-years wide, dwarf us beyond comprehension. Others, like Andromeda, our nearest neighbour, hold twice as many stars and shine more fiercely across the dark. We are not the kings of the cosmos, but quiet inhabitants of a mid-sized world, orbiting within a mid-sized galaxy in an ordinary corner of space. Yet, it is within this modest setting that something extraordinary happened. In a galaxy that ranks far from the top, life took root, fragile, improbable, and aware. Out of all the blazing spirals and radiant clusters, consciousness bloomed here, on a tiny rock circling a mediocre star. It's a cosmic paradox, that greatness, by the universe's standards, seems unrelated to meaning. The galaxies that burn brightest may fade first. Those that shout loudest may never pause long enough to listen. The Milky Way's modesty, in fact, may be the very reason we exist. A smaller galaxy spins more slowly, collides less often, and radiates less destructive energy. Its stars live longer, giving worlds time to form and evolve. Our sun was born in this gentle equilibrium, neither too close to the chaos of the core nor too far into the cold outskirts. It circles in a quiet region known as the galactic habitable zone, a band where conditions are calm enough for life to endure for billions of years. That serenity, the result of our galaxy's modest scale, may be the difference between existence and extinction. Astronomers often speak of the cosmic principle, the idea that there's nothing special about our place in the universe, but perhaps the Milky Way suggests otherwise. Its size, its calm, its long and measured history, all of these create the conditions for complexity. It may not be exceptional among galaxies, but it is perfectly suited for life as we know it. The universe doesn't play favourites, yet somehow we found ourselves in a place where the laws of nature allow wonder to arise. From the outside, the Milky Way is just another swirl of starlight, a grain of sand in the cosmic desert. But from within, it is everything. It's the sky that taught us to dream, the stars that guided our ancestors, the stage upon which our brief existence unfolds. The galaxy's modesty does not diminish its significance, it amplifies it. For in all its ordinariness, the Milky Way is proof of an extraordinary truth, that greatness isn't measured in scale, but in depth. Not in how much light a galaxy gives, but in what that light allows. And perhaps, in the end, that's the universe's quiet secret. That meaning belongs not to the largest, but to the ones humble enough to wonder. If our galaxy vanished tomorrow, the universe would barely notice. The local group would continue its motion, stars would still form elsewhere, and the grand pattern of the cosmos would go on, indifferent, eternal. It's a thought almost too vast to hold, that everything we know, everything we are, could disappear, and the universe would not flinch. No ripple would echo across the cosmic web. The light of neighbouring galaxies would still shimmer undisturbed. The expansion of the universe would continue its steady drift outward, carrying on as if nothing had changed. The Milky Way, this luminous swirl that contains our sun, our Earth, our entire story, would simply cease to be, and the cosmos would remain perfectly balanced. In that realization lies both tragedy and transcendence. It reminds us of our smallness, how little our existence weighs against the infinite, and yet it also frees us. The universe's indifference is not cruelty, it is the canvas upon which all beauty is drawn. The galaxies do not notice us, but they make our being possible. Their silence is not rejection, but space. Space for light to exist, for atoms to combine, for thought to arise. The local group, that small cluster of galaxies we belong to, would continue its slow dance regardless. Andromeda would still drift toward Triangulum, and the Magellanic Clouds would continue their faint orbit until they, too, were absorbed. The cosmic web would remain intact, filaments of dark matter still threading through the void, galaxies still glowing along invisible veins of gravity. The universe would go on painting itself in light and motion, one frame after another, heedless of what it loses or gains. From the scale of eternity, galaxies are like sparks, brief, bright, and easily replaced. The Milky Way is one of hundreds of billions. If one fades, another takes its place. And yet, from within, that spark feels like everything. We are creatures made of awareness, capable of seeing not just the stars, but the story they tell. If the universe would not mourn our loss, then it is up to us to give meaning to our existence while we are here. Perhaps that's the quiet lesson hidden in cosmic indifference. That significance is not bestowed but created. The stars don't care whether we notice them, but we do, and in that noticing, we bridge the infinite gap between matter and meaning. The very act of awareness turns emptiness into experience. So yes, if our galaxy vanished, the universe would continue, as it always has, vast, balanced, unfeeling. But for now, we are here. Looking back at it, we are the part of the Milky Way that knows it exists, the only fragment of this swirling disk that can look at itself and ask why. And that makes us, and our small, quiet galaxy, immeasurably rare. The universe might not need us, but it is through us that the universe finally becomes known. Viewed from far away, the Milky Way would appear as a faint silver line, just one of billions. To any distant civilization, our home would be indistinguishable from countless others. From the vantage point of another galaxy, the Milky Way would not command attention. It would hang in the cosmic dark as a soft streak of light, delicate and unremarkable, a thin ribbon stretching across the void. No one out there, no astronomer in some distant spiral, would see our sun or our planets, or the faint blue world that carries us. To them, our galaxy would be little more than a whisper among the endless symphony of stars. The Milky Way's light would travel for millions of years before reaching their telescopes. By then, the light they'd see would already be ancient, a fossil of what once was. Our current era, our world, even our sun, might have changed completely by the time their instruments caught our glow. To them, we would not be alive, but a memory written in photons, drifting endlessly across the dark. This is the humbling truth of cosmic perspective. No matter how magnificent we seem to ourselves, from far away we blend into the background. Galaxies like ours are everywhere. Some spin faster, some shine brighter, some host more stars or more chaos. The universe is filled with them, spirals, ellipticals, irregulars, each one a variation on the same theme. We are not special by design. We are part of a pattern. And yet, within that sameness lies something miraculous. Because among the billions of pale ribbons stretched across the night, ours happens to cradle life, at least one small world that can look up and wonder. From the outside, the Milky Way might look identical to its neighbours. But from within, it contains oceans, forests, clouds and eyes that gaze at the stars. That distinction, invisible from afar, makes all the difference. If some distant civilization were to look at our galaxy, perhaps they too would wonder whether it harbours life. Maybe they'd study its structure, its quiet arms, its modest glow, and speculate about the possibility of thought emerging somewhere inside. They would never know for sure, not unless the light we send, our radio waves, our signals, our whispers, ever reached them. And even then, those echoes would take millions of years to arrive, faint and nearly lost against the background hum of the cosmos. To them, we are invisible, and to us, they are the same, unseen, unheard, yet perhaps just as curious, just as aware. The pale ribbon that is our galaxy might be ordinary in the grand tapestry, but within it lies the rarest of all lights, consciousness. From the edge of the universe, our home would look like nothing more than a single shimmering thread woven into infinity. But threads, when countless, become fabric, and it is within that cosmic weave that all stories, including ours, are told. We may be just one ribbon of light among billions, but within this one, the universe is awake. The starlight we see from distant regions of our galaxy began its journey tens of thousands of years ago. We are watching our home as it once was, not as it is. Even our own galaxy hides behind time. Every night, when we look up at the sky, we are peering not into space but into history. The light that reaches our eyes, those faint beams from distant suns, has travelled across unimaginable gulfs of distance and time. Even the glow of the Milky Way, that hazy river of brilliance arching across the darkness, is an illusion stitched together by time delay. We are not seeing our galaxy as it is right now, but as it once was, a frozen image from thousands, even tens of thousands of years in the past. The farther away a star lies, the older its light. The photons striking your eyes tonight might have begun their journey when mammoths still walked the Earth, when glaciers covered continents, when human civilization was only a dream. Some of the faintest points in the Milky Way's outer regions send light that started its voyage long before the first words were ever spoken. What we see above us is not a living portrait, but an ancient photograph still arriving. Even within our own galaxy, light travels at the limit of speed. A beam crossing from one side of the Milky Way to the other would take 100,000 years to reach its destination. That means no one, anywhere, not even the most advanced civilization within our galaxy, can ever see it as it truly is in this exact moment. Every observer, no matter where they are, is bound by time's delay, locked forever in the past. The Milky Way hides behind its own light, veiled by the slow, patient speed of information itself. Astronomers often say that to look outward is to look backward, and that's never truer than when we gaze at our home. The light from the galactic center that we photograph today left long before humanity existed. Even the light from nearby stars, the ones we can name and recognize, is history in motion. The cosmos doesn't show us the present, it shows us echoes, the universe continually revealing what it was, not what it is. And yet, there's beauty in that delay. Time's distance grants the night sky its mystery. To see the galaxy as it was is to glimpse an unbroken chain of existence stretching far beyond our brief lives. The light of the past illuminates our present, linking us to moments we can never touch but can still witness. Perhaps the universe's greatest trick is that even now, surrounded by stars, we are watching ghosts, the faint memories of light that departed long before we could ever hope to receive them. The Milky Way we see tonight is gone, in a sense. But its light, still travelling, still arriving, still shimmering in our skies, reminds us that even after things pass, their essence lingers. Every glimmer, every photon, every faint shimmer across the darkness is a message written in the past tense, a quiet promise that nothing luminous ever truly disappears. Every telescope we build extends our sight, and yet, each discovery only reveals how much smaller our home really is. The more we learn, the less we seem to occupy. Humanity's story has always been one of expansion, of reaching farther, seeing deeper, and trying to find our place in what lies beyond. Every new lens, every observatory, every satellite launched into the dark was built to push back the curtain of mystery. And for a time, it worked. We saw the planets, then the stars, then the galaxies. We mapped the structure of the universe itself, but with each new revelation, a strange thing happened. The more we saw, the smaller we became. When Galileo first turned his telescope to the heavens, the Milky Way, once thought to be a smooth band of mist, dissolved into countless stars. The universe expanded. When Edwin Hubble looked deeper still, he discovered that even the Milky Way was not alone, but one among billions. The universe expanded again. And now, as the James Webb Space Telescope and Gaia stretch our gaze farther than ever, we find that even our galaxy, the grand stage of all our history, is far more modest than once imagined. The pattern continues. With every advance, the universe grows, and our importance seems to shrink. Each telescope we build acts like a mirror as much as a window. It shows us not only what's out there, but how little of it we truly occupy. The spiral arms we once thought stretched endlessly are revealed to be narrow and incomplete. The galactic halo we believed vast turns out to be thin, quiet, fragile. Even the boundaries of our gravitational influence are closer than we hoped. The cosmos is infinite, and our home, this beautiful swirl of stars is just a local detail. Yet, within that shrinking scale lies something extraordinary. Knowledge, paradoxically, expands us. The realization of our smallness doesn't diminish meaning, it deepens it. To see our limits is to understand where wonder begins. The edge of knowing is not a wall, but a horizon. And like all horizons, it calls us forward. Every new discovery, every recalibration of scale, brings the same humbling revelation that the universe is far grander than we imagined, and that our role is not to dominate it but to witness it. To observe, to understand, to feel awe, these are acts of participation, not conquest. Even now, telescopes orbit Earth, scanning the void with quiet patience. They gather ancient photons from the edge of time, translating silence into understanding. And every image they send home, of galaxies forming, of stars dying, of light bending, reminds us that we are part of something immeasurable. Perhaps that is the greatest discovery of all, that to be small in the universe is not to be insignificant, but to be perfectly placed for wonder. The Milky Way may occupy less and less of the cosmic map, but within it, a species has emerged that can draw the map at all, that can look into the endless dark and see not emptiness, but meaning. As data pours in, astronomers refine their models. The Milky Way's mass, diameter, and halo shrink with each update. Our cosmic identity is being rewritten, not as rulers of the stars, but as residents of a small, ordinary world. Every few years, the numbers change. The galaxy's weight, its width, its count of stars, all rewritten by new observations, new precision, new truth. What once seemed certain fades into revision. We are living in an age of correction, where every instrument aimed at the heavens redraws the boundaries of what we call home. The Milky Way, once described in textbooks as a giant among galaxies, now stands revealed as a middleweight, modest, measured, unassuming. When astronomers speak of the galactic census, they mean the ongoing effort to count and classify everything that makes up our galaxy, every star, planet, cloud, and cluster. It is a task both monumental and humbling, because the closer we look, the less we find. The Gaia mission, with its billion-star catalogue, has shown us not the immensity of our home, but its finitude. Its data traces the Milky Way's edges with exquisite accuracy, revealing that our disk ends sooner, our halo thins faster, and our total mass is lower than previous generations ever believed. Each update brings a smaller number, a quieter truth. For much of the 20th century, astronomers overestimated our size, mistaking distant satellite galaxies or background stars for part of our own system. But now, with improved instruments, we can distinguish the imposters from the residents. The borders of our galaxy grow tighter with every measurement. The Milky Way, it turns out, is not the sprawling empire we once imagined, but a compact, self-contained spiral drifting in a sea of larger neighbours. This gradual reduction has reshaped more than astronomy. It has altered our cosmic self-image. Humanity once believed Earth was the centre of creation, then that the Sun was, then that the Milky Way was, and now even that has been taken from us. We have fallen from every throne the cosmos ever built, and yet, in the fall, we've gained something more precious: perspective. Because smallness, when seen clearly, is not defeat, it is truth. The Milky Way's humbler status doesn't diminish its wonder, it magnifies it. To know exactly where we stand in the hierarchy of galaxies is to understand the scale of what surrounds us. To measure our home is to witness how delicate and improbable it truly is. And even as our galaxy's size contracts on paper, our reach as observers continues to expand. Every new telescope, every refined model, every recalculated figure adds another thread to the story. We may no longer be the rulers of the stars, but we are their chroniclers, the first beings, as far as we know, to weigh a galaxy, to question its shape, and to understand that it too is mortal. Our cosmic identity is no longer defined by grandeur, but by curiosity. by the quiet pride of knowing that even an ordinary galaxy can give rise to something extraordinary. The will to look back at itself and to ask, what are we, really, among the stars? Science has revealed what philosophy long suspected, that our place in the universe is smaller than we ever dared to believe, yet more precious because of it. For centuries, human beings have searched for meaning in the sky. We once thought the heavens revolved around us, that the stars were fixed lights, hung for our sake. Then we learned we were not at the center, but on the edge, not the masters, but the observers. Each revelation, each new layer of understanding, has stripped away a little of our imagined importance. Yet what remains, after all this humbling, is something deeper. A sense of wonder that does not depend on grandeur. The more the universe unfolds before us, the smaller we seem. The Milky Way, once thought infinite, is now merely a mid-sized spiral among billions. Our Sun, a quiet, middle-aged star. Our world, a tiny rock suspended in orbit. From one angle it looks like demotion, a steady descent from significance, but from another it is liberation. The vastness doesn't erase us, it defines us. It gives our brief existence its contrast, its meaning. Every discovery that humbles us also elevates us in a different way. To know that we are not the center of everything, but part of something boundless, is to recognize the improbable miracle of awareness itself. Out of all the galaxies, all the dust and light, we are one of the few parts of the universe capable of asking where we fit within it. We are small, but we know we are small. That realization alone makes us vast in a way no telescope could measure. Science has not destroyed mystery, it has deepened it. The shrinking of our galaxy, the redefinition of our cosmic borders, these are not losses, they are glimpses of truth. The Milky Way does not need to be the greatest to be beautiful, nor do we need to be central to matter. The real revelation is not that the universe is enormous, but that we belong to it completely. When we look at the stars, we are not gazing outward so much as inward, seeing reflections of the same matter that makes our bones and blood. We are part of the same fabric that binds galaxies, the same physics that governs the birth of stars. The humility that comes with that realization is not despair, but grace. Our smallness is the price of perspective, and in that humility, the universe becomes not a cold, indifferent void, but a living mirror, showing us that significance isn't given by scale, but by awareness. So yes, we are smaller than we ever imagined. But within that smallness is something immeasurable. The capacity to wonder, to feel awe, and to understand. The cosmos does not revolve around us, and that, perhaps, is its most beautiful gift. Perhaps the vastness we once assigned to our galaxy exists not in its size, but in our capacity to wonder. Consciousness itself might be the universe's greatest expansion. When we speak of infinity, we often point outward, to galaxies, to time, to the unending sprawl of space. But maybe infinity was never something beyond us. Maybe it's something we carry within. The Milky Way may be smaller than we once believed, but the mind that can comprehend its shape, its motion, and its meaning is boundless. Awareness stretches farther than any telescope because it can reach not only through space but through possibility. Every act of curiosity is an expansion, a small defiance against the silence of the cosmos. When we ask questions about the universe, we participate in it. When we imagine what lies beyond the edge of our galaxy, or beyond the limits of light, our thoughts cross boundaries no particle ever could. Consciousness transforms the finite into the infinite, turning the limits of knowledge into doorways of imagination. Astronomers often say that we are a way for the universe to know itself. It's more than poetry, it's physics. Every neuron, every synapse, every flicker of thought is made of atoms forged in ancient stars. The hydrogen in our blood once drifted through interstellar clouds. The calcium in our bones was born in a supernova. The universe does not simply exist outside of us, it continues within us. To look inward is to see the same vastness that we gaze upon at night. The shrinking of the Milky Way, the humbling of our scale, does not diminish that truth. If anything, it magnifies it. The smaller our physical place becomes, the more immense our inner landscape feels. We can hold entire galaxies in a single thought, trace the age of light in a whisper, imagine time itself bending around the gravity of stars. No measurement of matter can account for that capacity. Consciousness is the universe's most mysterious frontier, a space with no edge, no speed limit, no map. Perhaps that's the great secret hidden in our shrinking galaxy. That the infinite we sought in the stars was never lost, only relocated. It exists wherever awareness does. The cosmos may not revolve around us, but it unfolds through us. Even as we learn that our galaxy is smaller, our reach greater, our significance less, we expand in ways the universe cannot measure. Because the infinite isn't something we look at, it's something we feel. And maybe that's what makes the Milky Way extraordinary after all, not its size, but that within one of its countless stars, life arose that could look up and see the whole. When we stare into the night sky, we aren't just seeing the galaxy's limits, we're seeing our own. The Milky Way's smallness is a reflection of humanity's longing to belong in something greater. Every glance toward the stars is a confession, a quiet acknowledgement that we are searching for meaning beyond ourselves. For thousands of years, people have lifted their eyes to the same band of light, tracing its arc across the heavens, wondering where it ends and where we fit within it. The Milky Way has always been a mirror, not just of the cosmos, but of our inner world. In its spiraling arms, we've seen both our insignificance and our hope. As science peeled away the mysteries of the galaxy, revealing its modest size, its shrinking halo, and its average place among billions, something profound happened. We began to see that the measure of the universe is also the measure of us. The limits of the Milky Way are not boundaries that confine us. They are reflections of the boundaries we push against within ourselves. Each time we redraw the galaxy's map, we are redrawing the map of human understanding. There's a symmetry in that pursuit. The smaller the galaxy becomes, the larger our awareness must grow to contain it. When we learn that the Milky Way isn't infinite, that it is one small spiral in a vast web of light, we didn't retreat into despair. We reached farther. We built telescopes that see to the edge of time. We studied radiation older than stars. We turned data into images and equations, into visions of creation itself. The more the universe humbles us, the more determined we become to understand it. And in that balance, between cosmic smallness and human curiosity, lies something quietly sacred. The Milky Way's boundaries are a kind of mirror, reflecting not limitation, but invitation. They show us that scale is not about size, but about relationship. How far we can reach with thought, with imagination, with empathy. When we measure the galaxy, we are also measuring the reach of human wonder. The night sky, then, is not a ceiling, but a reflection of our own potential. Its smallness is our challenge, its vastness our reflection. The Milky Way does not make us insignificant. It gives us context. To know that our home is average among galaxies is to realize that meaning does not depend on magnitude. It depends on perspective. So when you look up at the faint milky band stretched across the heavens, remember, you are seeing both the universe and yourself. The same light that defines the galaxy illuminates your eyes. The same gravity that holds the stars together holds you to the earth. The Milky Way's smallness mirrors our longing, and that longing, the desire to know, to belong, to understand, is what makes us infinite. The Milky Way, it turns out, is not extraordinary. It's average, ordinary, a single spiral among billions. And yet, within its modest arms, life arose and learned to measure the universe. There is a kind of peace in that realization, a quiet truth that humbles and comforts all at once. For generations, we sought grandeur among the stars, believing our galaxy to be special, vast, unmatched. But with every new observation, every sharper measurement, that illusion fell away. The Milky Way is not a cosmic giant, nor a rare masterpiece of structure. It is, by every metric, typical, one of countless spirals drifting through the void, shining no brighter, living no differently than the rest. And yet, within this ordinariness, something extraordinary happened. Out of its billions of stars, one gave rise to a world of oceans and air. From that world came awareness. Eyes that could see, minds that could wonder, voices that could name the light. Against impossible odds, consciousness emerged from matter, and in doing so, transformed this ordinary galaxy into something unique. For no other spiral, no other cloud of gas and dust, as far as we know, has ever asked what it is. Astronomers often remind us that the Milky Way is unremarkable, and they're right. But that is precisely what makes it miraculous. In a universe of chaos and enormity, it doesn't take perfection for life to appear. It only takes balance. Our galaxy's calm rotation, its measured star formation, its quiet central black hole, all these small, unassuming details made room for stability, for time, for thought. If the Milky Way were larger, brighter, or more violent, perhaps we wouldn't be here at all. So perhaps the real wonder isn't that we live in an extraordinary place, but that the ordinary itself can give rise to such complexity. The galaxies that burn brighter will fade sooner, the ones that shine gently endure, and ours, small, modest, average, has lasted long enough to produce beings who can look upon it and understand. When you gaze at the Milky Way on a clear night, what you're seeing is not magnificence but grace. A collection of ordinary stars arranged just right to cradle something capable of awe. It is the universe's simplest truth, spoken softly across billions of years, that beauty does not require greatness and meaning does not require scale. The Milky Way may be unremarkable among galaxies, but within it, a single spark of life has turned darkness into understanding. And perhaps that's the quiet truth the cosmos has been whispering all along, that even the most average corner of existence can become infinite the moment it begins to wonder. Maybe that's the real revelation, that the edge of our galaxy isn't out there at all. It's here, within us, where curiosity meets infinity, and understanding turns smallness into wonder. For so long, we've searched for the boundaries of the Milky Way, tracing its spiral arms, mapping its stars, measuring its mass in hopes of finding where it ends. But every time we push the edge outward, it dissolves into something larger. The halo fades into the void, the stars blur into silence, and the horizon becomes unknowable. And perhaps that's because the true boundary we've been chasing doesn't exist in the stars at all. It exists in the mind. The edge of our galaxy is not a wall of light or a halo of dust. It's the point where human perception meets the infinite. Every discovery we make, every photograph of a distant nebula, every equation written on a page, stretches that edge just a little farther. Not because the universe grows smaller or larger, but because our awareness does. The cosmos is not something we stand apart from. It's something that unfolds through us, reflected in our thoughts, carried in our atoms, whispered in our dreams. When we look at the Milky Way, we're not just seeing a galaxy. We're witnessing the visible form of our own curiosity, the shape that wonder takes when given light. The stars that shimmer above us are the same elements that burn within us. The gravity that binds them together is the same force that holds us to our world. There is no true separation between what we observe and what we are. The edge of the galaxy is where that realization begins, the moment we stop looking outward for meaning and realize it has been within us all along. Science has shown us that the Milky Way is smaller than we imagined, its disk compact, its halo faint, its influence limited. But in that humility lies its beauty. Because though our galaxy may be modest in scale, its smallest corner has produced something the universe itself may rarely see. Awareness. The ability to ask, to imagine, to love, to wonder. The Milky Way doesn't need to stretch across eternity to be infinite. We make it infinite every time we understand it. So perhaps the true edge of everything is not a physical place, but a threshold of thought, the place where knowledge touches, mystery and awe begins. The stars fade at the horizon, yes, but the imagination continues. The light of the galaxy ends, but our curiosity does not. And when we close our eyes beneath that faint river of light, we realize something quietly profound. We are not standing at the edge of the Milky Way. We are the edge, the place where the universe turns inward and discovers itself. In the quiet drift of the cosmos, the Milky Way turns, small, unhurried, content to glow in its corner of infinity. We once thought it was endless, a boundless empire of light, but now we know the truth. It is humble, fragile, and beautifully finite, and somehow that makes it even more extraordinary. For within this modest swirl of stars, consciousness awoke. It looked outward, saw the limits of its home, and found meaning not in its size, but in its wonder. The galaxy may be smaller than we dreamed, yet the curiosity it inspired is limitless. So, as the night deepens and the stars fade from view, remember, the edge of the Milky Way isn't out there, it's within you, where understanding meets awe and smallness becomes infinite. Sleep well, traveller of the stars. The universe is vast, but tonight you are home.